Welcome to lesson 8 of our Power BI course. This course is titled Data Visualization with Power BI. And in this course, we are covering all the major concepts in Power BI for us to understand it, not only theoretically, but also practically, so that we can apply these same skills in the industry and at the same time prepare for the Power BI examination. Yes, we have worked on a number of projects, and we have one major project to work on. This is why we need to continue this class. This is why we need to finish it well and understand it so that our projects will be completed. Yes, so we want to continue so that we don't break the chain of learning that we are doing. So I like to encourage you, as I always do, and let you understand that all things are difficult before they are easy. Before anything is easy, at first it will be difficult because you're a beginner. And so it takes time. The expert at anything was once a beginner. Anyone who has succeeded in any skill was once a beginner, and it was difficult. And so, even though things may look difficult in the beginning, you don't have to give up. You have to keep learning. You have to stay with it, and you will understand it. So, Power BI is easy. DAX is easy. DAX is easy. So, please, if you are here, put that in the chat for me. DAX is easy. Even though it appears difficult, it is easy and you will understand it. Yeah, so in this class, we will make sure you understand it. So this is myself, and I welcome you to this wonderful class, Power BI, Microsoft Certified Power BI Data Analyst Associate Certification. And once we are done with the studies, we want to encourage you to take the examination and get certified in Power BI. This is a certification you will need. And at Rate Africa for data students, this moving forward is going to be the yardstick for graduating from specialization into mastery phase. We've covered several topics, and now we are on lesson 8, which is a live session on the DAX expression language. And so we want to spend some time and study about the DAX expression language, to get into it, to understand it, to know what it is, to know how it works, so that we can implement it in our data visualization with Power BI and in our data models within Power BI. And so this lesson is lesson 8, titled Data Analysis with DAX in Power BI. The data analysis expression language, that is what DAX stands for creating calculated measures, business logic, and custom expressions within Power BI. By the time you spend time on this, you will realize that you are gaining understanding into it and you are becoming confident in it. By the end of this lesson, we want you to be able to confidently on your own write, apply, and interpret DAX expressions like a real-world data analyst. You will be able to create calculated measures. You'll be able to create conditional logic, and you'll be able to build custom calculations for dynamic, insightful, and context-aware reporting in Power BI. By the end of this lesson, you are going to understand that DAX is really the secret behind the interactivity of Power BI. What makes Power BI not become boring? What makes Power BI not become static? What makes Power BI to be so interactive and to be so dynamic? The reason is DAX. And so if you are serious about data analytics and Power BI data visualization, business intelligence, you need to spend some time and understand DAX. DAX is important. It is a language, and as a data analyst, you need to understand it. From all the research we've done, you need to understand this. If you are studying Power BI, this is something really to understand to complete your knowledge. So DAX, the first question here says, what is DAX? What is DAX? And DAX stands for data analysis expression. Data analysis expression. So this is a language called DAX, and it is called data analysis expression. That is wonderful. So there are multiple languages in tech, and they all have wonderful names, but they all have meanings. They all stand for something. For example, when you say SQL, SQL stands for something. And if you know it, please put it in the chat for me. SQL, what does SQL stand for? SQL, yes. For DAX, DAX stands for data analysis expressions. And SQL, in the chat, someone says that SQL stands for, let's see what Paul will write. And David says that SQL stands for structured query language. So structured query language, it is a language, and we call it SQL in tech. Some people call it SQL, all right? But this name has a meaning, stands for something. And if you get into it, you will know that it is a query language. That same way, DAX stands for data analysis expressions language. Data analysis expressions language. So if you think about this, this is really important for data analysis. And the expressions part tells you that it's made up of a lot of arithmetic expressions, mathematical expressions, and understanding this will let you understand the mathematics behind Power BI and the interactivity in Power BI. So DAX is a formula language. DAX is a formula language. If you look at SQL, SQL, structured query language, that is a query language. So right from the meaning, structured query language, it is a query language. So we use it to query databases. We use it to extract data from databases. We use it to make requests to database. That is why we call it a query language. For DAX, DAX is a formula language. And so we are going to understand why it is a formula language, and we are going to understand that it is made up of formulas. And so understanding this makes it easy for you to know what you are dealing with and how to apply it. All right. And we are going to be comparing DAX with Excel most of the time. And this is going to give us an idea of how we'll be able to understand it, because most of you understand Excel already. You can write formulas in Excel. You understand the rules of Excel formulas. All right. So if you bring that same idea into DAX, you understand that DAX is also a language that is made up of formulas just like Excel. All right, so to clarify this, we want to compare this with other programming languages. So we say that DAX is a formula language. And to understand what that means, let's compare it with other languages in tech. So if you take Python, Java, and JavaScript, those ones are called programming languages. We use them to build software applications and perform complex logic in computer programs. So that is called programming languages. Now, all the other languages that, for example, SQL is not really a programming language, because we don't use SQL to build software. We don't use SQL to build software. So SQL or SQL is referred to as a query language, and it is used to retrieve and manipulate data in databases. HTML is not a programming language. HTML is called a markup language. It is used to structure content on the web. So because of what it does, its name bears what it does. And so HTML is a markup language. And then CSS, which stands for Cascading Style Sheets, is a styling language. If you look at HTML, who can tell me what HTML stands for? Let's put that in the chat if you know what HTML stands for. And you realize that the name is embedded in what HTML is. and it is a markup language. For CSS is a styling language. So CSS is not a programming language. And so when you are listing programming languages, you do not include CSS. CSS is used for styling, and it is used to style and format web content. That same way, with that same idea, DAX is not a programming language like Python, like Java, like JavaScript. DAX is a formula language, and it is used to define calculations and expressions in data models. For example, in Power BI. So this is to let us understand that there are multiple languages in tech. We have query languages, we have markup languages, we have programming languages, we have styling languages, and this is a formula language. All right. So that is a formula language, and a formula is an expression used to calculate a result. So once we say a formula language, we are trying to explain what a formula is, and a formula is simply an expression that is used to calculate a result. Now, in math, a formula is something like area equals to length times width. In math, this is how a formula looks like. In Excel, this is how a formula will look like. But in DAX, a formula will look something like this. All right, a formula will look something like this in DAX. So this is to let you know how DAX formulas will look like. And this right here is another example of a DAX formula. And so the DAX that we are studying, this is how it is going to look like. And this is how we are going to be writing our DAX formulas. So this is a simple DAX formula. And as you study DAX, you will be writing simple formulas like this. And this is very easy to understand. It says amount is equal to quantity times unit price, all from a sales table. And once you are using Power BI makes it very, very easy for you to be able to write this, because Power BI uses IntelliSense. And as you start writing, Power BI will just be dropping down for you, and it's very, very easy to write this. So you can create a formula like this, and this particular formula will create what is called a calculated column. A calculated column. So please, let's put that in the chat. If you can hear me, type calculated column in the chat for me. And this calculated column is called amount. So this particular formula is going to create a calculated column called amounts in the sales table. So the reason why we have sales and then the bracket quantity is because we are dealing with a table called a sales table, and we are multiplying each row's quantity by 8 units price to give the line item total for every transaction. And once we create this calculated table, this is how it's going to look like. Calculated column, this is how it's going to look like. And so this means that we have an original data set that has all of these columns already. And once this formula is written in DAX, this formula is going to create a calculated column. And so it is going to include a column next to your table so that you can operate with it. So as we go through the lesson, we are going to explore what calculated columns are and how we can create it, because there are some key elements or key components in DAX that once you explore them and understand them, you get to build a foundation to be able to understand it well. All right. So apart from simple formulas, we also have complex formulas that we will be writing as we advance in DAX. So over here, you can see a formula that calculates total revenue, also calculates cost, calculates profit, and calculates profit margin. And so your journey in learning DAX is for you to begin with simple DAX formulas and be able to understand how to write complex DAX formulas. The rules are simple, the rules are the same, and so Once you understand it, you realize that it is not difficult at all. And the complexities, that is what we hope to break down in class. So far, we've defined what DAX is, and we've been able to understand that DAX is a formula, language. We've been able to compare what we mean by formula language with other languages in tech. And we establish that there are multiple languages in tech. We have styling languages, we have markup languages, we have query languages, and we have programming languages. All right. And so when we say a formula language, we are talking about a category of writing code to solve certain results. Yes. So this is the context we have built so far. Next, we want to talk about how DAX is used in the field. Now, DAX is used in number one, Power BI. Power BI uses DAX. Number two, Excel Power Pivot uses DAX. So just like we explained in our previous lesson, DAX is used in a tool called Power Pivot. Power Pivot is an application just like Power Query. If you remember Power Query, we use Power Query. Or let me ask you, which environment did we use Power Query the last time? So if you remember how to use Power Query, and if you used Power Query before, which environment did you use Power Query? So anyone who remembers how we used Power Query the last time, let me know in the chat. And Paul says that Power Query was used within Power BI desktop. That is beautiful. So that same way that we're able to use Power Query within Power BI, that same way in Excel, we have Power Pivot within Excel. And in Excel, we also have Power Query within Excel. So if you're in Excel, you can use Power Query. The same Power Query you use in Power BI, you can use it within Excel. So Excel allows other applications to load through it. And if you run Power Pivot within Excel, it is used to create data models and relationships in Excel. It's so amazing that Excel will allow you to establish relationships now because of Power Pivot. If you have Power Pivot, you can build a data model within Excel. You can establish relationships amongst multiple tables within Excel. You can perform calculations within Excel with DAX. So DAX is fully used in Power Pivot, and Power Pivot is used within Excel. DAX is used in Power BI, and DAX is also used in SAS. SAS stands for SQL Server Analysis Services, and its tabular model uses DAX for its data models. And so this is another tool that in future you will be exploring. It's called SAS or SSAS, and Power DAX is used in SAS. And SAS has two models, multi-dimensional models and the tabular model. The tabular model uses the DAX the same way we use it in Power BI. And so as a data analyst, when you learn about DAX, you are able to apply it in multiple applications. And this is really, really important. That same way, when you learn SQL, which is one of the tools that data analysts should understand, you apply it in multiple environments. All right. Apart from that, Azure Analysis Services also uses DAX, and Microsoft Fabric also uses DAX because Microsoft Fabric has Power BI in it, and the Power BI we use in Microsoft Fabric, we definitely need to use DAX in it. So this tells you that learning DAX will really prepare you for a better tech career as a data analyst. And this is something that you need to attack, or you need to treat with a lot of seriousness. You need to approach or attach a lot of seriousness to it to be able to understand and advance your level and your skills in data visualization. So within Power BI, which is a business intelligence tool and a data visualization tool, the role of DAX is used to create calculated columns. So please write in the chat calculated columns. In the chat for me, calculated columns. So in Power BI, we are talking about how we use DAX In Power BI, we use it to create calculated columns. We also use DAX to create what is called measures. We also use DAX to calculate custom tables. So please type measures in the chat for me. Type measures in the chat for me. Measures in the chat for me. So we are talking about how DAX is used. So if you are new to DAX, if you've not heard anything about DAX, it is very helpful for you to understand that DAX is used in these applications. It's used in Power BI, and in Power BI, we use it to create calculated columns. We use it to create measures. We also use it to create custom tables in data models. So these are concepts in Power BI that we will be getting into. And by the end of this lesson, you should be familiar with what is meant by calculated columns. So as I ask you to type it, I'm just preparing you to understand it, and measures as well. Now, in Power Pivot is used for advanced data modeling and analysis inside Excel. And Power Pivot uses DAX. The role of DAX is used within Power Pivot adding to build relationships, calculations, and KPIs on large data sets. So just as we use it in Power BI, in Power Pivot, we also use DAX. Microsoft has a lot of Power Apps, and so they have PowerPoint, Power Pivot, Power Query, Power BI, Power Automate, and if anybody remembers any of the Power Apps, you can put it in the chat for me. Number 3, SQL Server Analysis Services, or SSAS, tabular model is an enterprise-grade data analytics tool for building data models for business intelligence solutions. So this means that as you move from specialization to mastery to advance, you are going to be dealing with enterprise-grade tools. Some are cloud-based tools. Some are enterprise-grade tools that are just used for data models and analytics for large organizations and high-end applications. And SAS is something like that. And the core formula language for performing calculations in SAS is the same DAX. It's also used for creating measures and expressions in the tabular models. In Azure Analysis Services, which is a cloud-based version of SAS tabular model for enterprise analytics. So Azure Analysis Service from Microsoft, the same SQL Server analysis software or services, tabular model. There is a cloud-based version, which is called Azure Analysis Services. Yes, so in the cloud, this is how it is called. So this is why in Azure, you will use the same DAX, same as SSAS tabular, to define your measures, your KPIs, and your calculated tables in your data model. So that is it. So as you apply it, you use it everywhere. And also in Microsoft Fabric, which is a unified data platform that integrates Power BI, Synapse, and Data Factory, uses DAX within the Power BI experience within Microsoft Fabric for data modeling and analytics. So you can see that the core tools are Power BI, Power Pivot, and SSAS tabular model. However, these two tools are also used in the cloud and also in Microsoft Fabric. All right, so let's think of DAX like Excel formulas, but more powerful and made specifically for Power BI. So the reason why we tell you to think of DAX as Excel formulas is because you are already familiar with Excel formulas. You understand the rules of Excel formulas. You know that to write a formula in Excel, you need to begin with an equal to sign and probably use a function and then open parentheses and then put in a cell range from cell A1 colon cell whatever. So you have an idea of how Excel formulas look like. So what we are saying is that DAX also looks like that. DAX looks like that, just that it is more powerful and advanced. And so as you have studied Excel, you will also understand DAX, which is advanced and built for Power BI and the related tools. Now, let's talk about why DAX. And the first point here is that DAX is the engine that powers intelligence in Power BI reports. DAX is really the engine that powers intelligence in Power BI reports. Very soon, we are going to see that anytime we want to extract any intelligence from Power BI, it is DAX that does that. For you to say that, what is the total sales of this particular product? For you to be able to ask this question, it is DAX that can do it. And so you need to use DAX to request for that information. That same way, it's like having a database and having SQL. With SQL, you can extract any intelligence you want from your SQL database or MySQL database. That same way with DAX, you can extract any intelligence from your data set that is imported into Power BI. DAX gives you full control over your calculations, your KPIs, and logic. So any calculation you want to perform, any calculation you ever want, you need to use DAX. So DAX is really important. You cannot learn Power BI without DAX. And the way we are structuring this DAX lesson, we want to focus on DAX and let you build a foundation that will make you used to DAX and have the confidence to work with DAX. So in your data set, we have key performance indicators that DAX allows you to extract. For example, if you have a sales data set, one KPI will be, who can give me one KPI in a sales data set? So a company that is recording sales, what do you think they want to know at the end of the day? If a company is recording their sales in a table, what do you think they would like to know at the end of the day? All right, they would like to know their total sales for the day. They would like to know their total sales for the month. They would like to know their total sales for the year. So this is a major KPI that tells them whether they are succeeding. Another KPI will be what? Apart from total sales, what will be another KPI in a sales data set? So another KPI, someone says, apart from sales, we can also have in the same sales data set, we can know, apart from total sales, we can know profit margin. Thank you so much, David. You're on point. All right. Who wouldn't want to know their profit margin? You like to know your profit margin. So profit margin is an important KPI. All right. So you want to know total sales. You want to know your profit margin. You may also want to know the costs that you are incurring. All right. And all of that data is in the table, not analyzed. But with DAX, that gives you control over all the KPIs you need, all the calculations you need for you to understand it. So this is important for us to understand. And DAX transforms static reports into interactive dashboards. So the reason why Power BI is so interactive, that's when you click on one thing, it affects other things. It is because of the DAX language. DAX also supports something amazing that we call time intelligence. Time intelligence. It also supports conditional logic, and it also supports comparative analysis. So as you progress, we are going to talk about all of these. So this should let you understand why we need DAX and why DAX is important. Now, who is DAX for? DAX is for a business analyst. A business analyst is a data analyst who applies their data analytics skills to solve business problems. For example, to solve marketing problems, to solve sales problems, to solve finance in a real company. And mostly in the business context, if you are not using your data analytics in education or for school purposes, for other research purposes, and you are using it in the context of business to help a company, you are called a business analyst. And we also have data analysts, we also have data scientists, we also have developers or engineers, we also have students and learners, and we have any Power BI user. So who is DAX for? Who is DAX for? So I'm treating this as an introduction to DAX, and we've covered what it is. We've covered that it is a formula language. We have covered that DAX is used in multiple applications like Power BI and so forth. And now, who is DAX for? DAX is for you if you are among this category. The next slide talks about the uses of DAX within Power BI itself. Now, within Power BI, one of the top uses of DAX is to create calculated columns. So please let's type that in the chat one more time, calculated columns. So within Power BI, there is something we call calculated columns. And to create that, we use DAX. Thank you so much. Thank you so much. Calculated columns. And we use DAX for that. So in Power BI, how are we going to use our DAX? Number one is to create calculated columns. Number two, to create measures. So you can see that since I started this introduction, which is leading us to the depth of Power BI, sorry, of DAX, which is leading us to the depth of DAX, I have mentioned calculated columns multiple times. I've mentioned measures multiple times. And so if you have forgotten what these are, we want to revise over them. And if you do not know what these are, we are going to talk extensively about them because they are the two top reasons why we use DAX. And they are the two common uses of DAX within Power BI. When anyone is creating using DAX in Power BI, it is either they are creating calculated columns or they are creating what is called measures. All right. Now, number three, it is also used to create or build what is called calculated tables. Calculated tables. And we also have what is called to perform time-based analysis or what is called time intelligence. So DAX is used to perform time-based analysis. We will read more about it and understand that time-based analysis are analysis that are based on time, like monthly, yearly, weekly. Those are analysis that are based on durations or periods or time. So we call that time-based analysis. We'll talk more about that. And then also, DAX is used to build interactive and dynamic dashboards. So these are the top 5 uses of DAX within Power BI. And we will be exploring them one by one as we get to understand what DAX really is. And when we say a calculated column, let's start with that. So the calculated column we'll be talking about, when we say calculated column, in Power BI, calculated columns are new columns that are added to your data model using DAX formulas. What this means is that if you look at the table here, the original table had column 1, column 2, but you can see that a calculated column has been created. Now, if you look at this calculated column, what is happening is that the amount we have in the calculated column is being extracted from column 1 and column 2, and the calculation we are doing here is to add column 1 plus column 2. So if you add these two, you get this. If you add these two, you get that. And so the calculated columns are new columns that are added, and they are added based on calculations from our existing columns to arrive at a value for the new column. They are useful when you want to perform row by row calculations using existing columns in your data set. So the existing columns are there, and you can create a calculated column. For example, you may have a column called first name in your data set. Most databases record first name. You can have another column called last name. But then sometimes you may need full name. But in the original database, full name was not recorded. And so you may want to find a way of combining two columns to create a new column. So in Power BI, you can do all of that. And mostly we use DAX for these calculated columns. When there are numerical calculations too, you just perform the calculation and it will be able to create those columns for you. Sometimes you are asked to create these new columns within Power Query, because in Power Query, if we remember, you can create multiple columns within your data set before bringing it into Power BI. However, within Power BI, you can also create calculated columns and you can perform those calculations using DAX. All right. Now, when we say calculated measures or measures, in Power BI, measures are dynamic calculations used to summarize data, such as totals, averages, percentages, and total and ratios. All right, so what do we mean? What this means is that in Power BI, you may want to measure something, you may want to calculate something, which is not a column, but a measure that can bring out a certain value that you are looking for. For example, you may want to find the total sales of your sales data sets. To find a total sale, you need to create a measure that will go into the data set and perform that calculation. And so that kind of calculation is referred to as a measure. And to create a measure, you need to write some DAX code, give it the instructions, and it will go and perform that calculation for you. And it will be stored as a measure. And that measure can be used for your KPIs or for building your visuals. All right. We also have what is called calculated tables. And in Power BI, calculated tables are new tables created by DAX formulas. These tables let you add a derived table to your data model. So not only can you create a column and add a column to an existing table, you can also fetch data from multiple tables to create a whole new table. So that is called calculated tables. And DAX can allow you to do that. This doesn't happen most of the time. The top uses are calculated columns and measures. However, you can use DAX to also build a whole new table right from DAX. So if you look at the code here, we are using a function called union, and we are joining table 1, table 2, and we are creating a new table called calculated table. All right. DAX is also used for what is called time-based analysis. In Power BI, time intelligence functions allows you to manipulate data using time periods, enabling trends and comparison over time. What does this mean? This simply means that in DAX, we have certain functions that are designed for time intelligence. For example, total year to date. It is a function. Its job is to perform calculations based on a certain date for the whole year to date. So anytime you call such a function, it performs a periodic calculation. And this is very useful within Power BI. And so we use DAX to do that. We have several time-based analysis functions. And with those functions, you can perform analysis that will extract intelligence based on periods, either months, years, weeks, and so forth. And then lastly, about interactive dashboards, we use DAX to drive visuals that respond to our filters, our slices, and user input, making reports truly dynamic. So DAX is what makes our dashboards and reports interactive. When we use DAX, when we want Power BI to answer specific business questions, like what's the total sales for each month, what product is the most profitable, how many customers place more than one order, what is the average order value per customer, what percentage of sales came from repeated buyers. What does this mean? What this is referring to is that if within your Power BI report, you want to answer a question like this, what can be used to get the answer is DAX, or to tell you the importance of DAX. So if you want to know your most profitable product, it is DAX that is used. In short, DAX is used to make Power BI reports and dashboards smarter and more interactive. All right. Next, let's move to what is called the core concept of understanding DAX. And what I have put in these slides, they are the pillars of DAX. They are the pillars of DAX. And so if you can understand these pillars, then you have a solid foundation to understand DAX. And if you have no clue what these pillars are, then what it means is that DAX is going to remain a mystery. For example, we mentioned calculated columns. Maybe you've not yet understood what a calculated column is. We will try an example and you will see it. It is a pillar in understanding DAX. What is a measure? You need to have in your mind what a measure is without any confusion. All right. So if right now you've not understood what a measure is, we will try an example to let you see it in action. But as we continue the lesson or the subject of DAX, you need to be clear in your mind 100% what a calculated column is, what a measure is. And if you know these things, then you are someone with a level of intelligence that can absorb the language of DAX. And so I'm going to talk about a number of core pillars. So the core DAX concept, number one, we have one core concept that is called row context. Please type that in the chat for me, row context. Row context. Let me see the first person to type row context in the chat for me, row context. So this is one concept that you need to understand. So thank you, Bernadine. Bernadine is in the house. All right, welcome, Bernadine. Okay. So at this point, if you have understood what calculated columns are, good for you. If you've understood what measures are, good for you. But you also have to understand what row context is. What in the world is row context? This is a pillar of Power BI DAX. And just like I said, without unmistakable understanding of these things, the ability to understand DAX becomes a mystery or remains a mystery. For example, in data modeling, before, concepts like fact tables and dimension tables were mysterious until you understood them. And when you understood them, some way, somehow, you just realize that you understand what fact tables are and what dimension tables are. Someone who hasn't studied has no clue what these are. This means that person doesn't have the prerequisites or the foundation to be able to build on top of that. All right. So to understand DAX, there are certain concepts that you should just understand. The same way you understand what fact tables are. Once you understand this, then you have the foundation to build upon it. So I'm going to talk about these concepts. First, I'm just going to list them and then I'll take time and talk about them. Once we are able to establish what they stand for, what they are, then we are now ready to learn DAX. This is why I'm doing my introduction again. The next concept is called filter context. So please type filter context in the chat for me. Filter context. So we have row context, we have filter context, and the next one is, of course, calculated columns and measures. We've talked about them over and over and over and over and over and over. By now, most of you are already understanding what these are. All right. Number 4, we have something called context transition, which is still connected to row context and filter context. And lastly, we have what is called the DAX syntax and the DAX functions. So if you look at all these core concepts, you understand that knowing what these are, row context, filter context, calculated columns and measures, context transitions, and the DAX syntax. So we look at how the DAX syntax looks like, and then the DAX functions. We just talk about the basics, and once we understand the basics, then we have what it takes to build upon it. Once this foundation is set, we will be able to learn and understand DAX. So in this lesson, we are going to use this time to set this particular foundation to understand these prerequisites. And in the next lesson, we will have the second part of this lesson to deal with the real codes and the logical and the conditional logic and all of the various aspects of writing DAX code. With these foundations, we will be able to understand them. So let's start with the first one, row context. So I'm just going to try and explain what these things are. If you can understand row context and filter context, then you've made a lot of progress and you are ready to demystify what DAX is. All right, so let's talk about row context versus filter context, and then we'll talk about them one at a time. Understanding row context and filter context is crucial for anyone learning DAX. These two concepts determine how calculations behave in Power BI and are the foundation behind functions like calculate and functions like SUMX and many more. So what we are saying is that these two concepts, they are really crucial. They are just concepts for you to understand, but then they are the secret behind understanding DAX. So the 5 things we listed, those things, once you get them in mind, then you will be able to really apply DAX. Now, what is context in the first place in DAX? In DAX, context refers to the environment or filtering frame. Please type environment in the chat for me. Environment or filtering frame in which a DAX formula is evaluated. The environment in which a DAX formula is evaluated. So once you type environment, that will be the first step to understanding this. All right. So we are saying that there is a frame for filtering, or there is an environment in which DAX formulas are evaluated. Now, we understand that DAX itself is a formula language, and it operates under the context of these two environments. So one is called row context, and one is called filter context. Now, think of row context as a row by row evaluation. And think of filter context as a filter applied to a table or a column before calculation. All right, so we'll get into details, but at least knowing what they are, what they stand for, is really important. We have row context and we have filter context. So what we are trying to say is that every formula in DAX has two modus operandi or modes of operation. What mode does it use? Or what context does it use? Does it work with a row context or does it work with a filter context? So these are just ideologies or concepts, but having this understanding is a secret behind DAX. All right. So these concepts determine which data is included in a calculation and how it is processed. So let's take it one at a time again. When you say row context, there are certain DAX operations that chooses the first context, which is called row context, and it operates by row context. So your job as a DAX learner is to look at your DAX formula and understand whether this is row context or filter context. Let me say one thing about it before we read more about it. So there are two contexts or two environments. There are certain DAX operations that will use the row context. The row context, what it does is to process data row by row. And what we mean by context, all we are trying to say about context, we are talking about data processing. Please put that in the chat for me. Data processing. Please put that in the chat for me. Data processing. All right. So let's enter into an imaginary world right now. And let's think about how that works behind the scenes. There are certain DAX operations. If it has row context, what that means is that behind the scenes, it processes data row by row. It processes data row by row. And so what happens is that because it has row context, and again, these are concepts that you should just understand. Understanding them increases your vocabulary and gives you the foundation to understand DAX. All right. Row context means its approach to data processing. It processes data through your data tables, your data sets, row by row. And so if it is performing any operation, if it has row context, or if it uses row context, this means it only operates by a single row at a time. Every calculation will be done on that row, and it only zooms into that row and perform all of its operations within that row. When it is done, it moves to the next row and the next row and the next row and the next row and the next row, and it performs its calculations by row context. And it processes data or the tables by row context. That means row by row, row by row. Please type row by row in the chat, row by row in the chat. By the time I'm done explaining, you will understand. I know you've not gotten it yet, and I know you will get it. So just type row by row in the chat. All right. Now, number two, we have what is called filter context. And filter context is another approach to data processing within DAX that before it processes or performs any calculation, it will apply a filter to the data And then after the filter is applied, then it goes ahead to perform its calculation. For example, if you have a data set that has filters and slices, and you see a chart called gender distribution, and you click on female, what do you think is going to happen? Okay, what is going to happen is, first of all, filter context. What it means is that you are informing the engine and the intelligence of Power BI that I am creating a filter. Focus on this filter and perform any calculation based upon this filter. Now, this filter, based on what the filter is, will create a subset of the data set or the whole data model, and the calculation will be performed on the filter. The filter doesn't have to be a row. It can be a whole subset of the whole data set or a whole category of the entire data set. All right, so two questions. When you are using DAX, you need to start trying to figure out whether this is row context or filter context. And so we are going to perform certain tasks, and you will tell whether this is row context or this is filter context. All right. Before that, let's read a little bit about each one, and we will build upon the understanding. So when we say row context, it is a concept in DAX that exists when a formula processes data one row at a time. It is automatically created when Power BI is calculating a calculated column. So if you've created a calculated column before, you know that this is called row context. Or it is using a function like SUMX. So after we explain row context, we will do a quick demo for you to see row context in action. Again, this is just a concept, and what you have to do is to try and understand what this concept is, because this is what becomes your foundation and allows you to learn Power BI really well, and that's well. Now, row context tells Power BI which row it is currently working on. This allows DAX formula to access the values of other columns in the same row. In simple terms, row context is the environment where Power BI focuses on one row at a time, reads its values, calculates something, and then move on to the next. And so if you know what calculated columns are, you will know that calculated columns operate row by row. Okay. So let's look at this slide here. It says that row context exists when DAX evaluates an expression for each row in a table. It is automatically created when you add a calculated column. All right, so this is a picture of calculated column again. We will be creating our own calculated columns. And you can see that this particular calculated column, it wasn't part of the original data set. So you just created this. But the moment you added the calculated column, a row context was created to allow DAX to process the data or to process the calculation, let me put it that way, to process the calculation row by row. If you look at this, you can see what kind of formula was used here. Who can tell me the formula that was used here to perform these calculations? By looking at column 1, column 2, and the calculated column, what formula was used? What formula was used? Okay, so let me see who can put that in the chat, and then Just look at it, you can tell. I mean, you can just tell. All right. Okay, so multiplication. I like that. So you can see that column 2 and column 3 were multiplied to create the calculated column. Now, this calculated column is just a simple act of adding a column that doesn't exist, but you need. But the moment you want to create a calculated column, the DAX formulas operate with what is called row context. How does it process the data? When this data is being processed, it is processed row by row. So you can see that it focused on this and followed the formula, which said column 2 times column 3. Now you said column 2 times column 3, but it actually performed it here. Column 2 times column 3 is 50. Then after it was done, it moved down to the next row. Column 2 times column 3 again, 120. When it was done, it moved down to the third row. Column 2 times column 3 again, 240. So this is what we call row context. It is just a concept and it defines how data is processed when DAX functions are activated. All right. So at this point, you just have to look at certain actions in DAX and determine whether this is row context or filter context. All right. Okay. So put simply, row context is the idea that Power BI looks at one row at a time when calculating something. So what context does it use? If it is row context, it means that it looks at one row at a time. Now, calculated columns automatically have what we call row context. So if you have a calculated column, it automatically has what we call row context. Because you created that calculated column is still active every time. You can even go and manipulate the formula again. But then you have to understand that that formula has what is called row context. It's just a concept. What does it mean? It means that that formula processes data one row at a time. Number two, if you create a measure doesn't have row context because a measure is not like calculated column that creates or that processes data row by row. A measure can perform its calculation anyhow. So if you have a measure, it will not have row context unless you implement a function within your measure, like the function we call SUMX, to create your row context. So please type SUMX. SUMX. All right. So this is not a sum function. This is SUMX. SUMX is a senior brother of sum. SUMX is an iterator function. What this means is that it is able to perform sum in a loop. And it's a special sum function that will not just calculate by one field. What this means is that whatever formula you put in SUMX, it will iterate it. It will iterate it. And it will run through a loop. That is what the X stands for. We will demonstrate it and you will see it in action. So a beginner trap to avoid. I know a lot of people are wondering right now. Don't overthink it. Just remember, If Power BI is calculating something row by row, then row context is happening. So when a Power BI task or formula is processing data row by row, what context is it operating in? Who can answer that question? What context is it operating in? When we started, I mentioned what context stands for. And I said context refers to the environment in which the DAX formula is evaluated. Which environment is the DAX formula evaluated? Which environment? So if you are creating a calculated column, which environment is your formula being evaluated? So we call that the context. Which context? And someone says row context. I don't know if Bernardine is the only one in the class. All right, so we have row context. All right, now let's do a quick demo to understand row context. And this is just a virtual environment, or for now, an imaginary environment which really exists, but you understand it just by understanding. It is not something that you can see and point at. But let's try and see if we can even point at it. So let me share my screen well, and we will go ahead and try the row context. So now that I've shared my screen properly, let me launch Power BI. And I will just use this DAX formula to create a calculated column to compute revenue. After the calculated column is created, I'm going to ask you what environment or what context that formula is being executed. All right, so in Power BI, we can import a data set. Let's go to blank report and let's go ahead and get data. Let's get data and let's get from Excel workbook. And we are using this data set. So I shared it with you the last time. And today we'll be using it again. By the time we are done with this lesson, we'll be using multiple data sets that I will be sharing with you. So this simple data set, let's import it. Okay. So over here, let's click on sheet 1 and let's load it. And once it loads, what we will do is to rename it from sheet 1, to what is called sales. So we have it right here, sales. Now that we have sales, we can right click on sales and create what is called a new column. When you click on new column, you can see that it has placed it here. And over here, you have the formula bar to type your DAX over here. So this is one way to create your calculated column. Also, on the modeling tab, you can just come here and say new column. And you have the same result. You can create your calculated column. Before we do that, let's go to the table view over here. The table view, because this is the DAX query view, which we'll be looking at later. This is the model view. This is the table view, and this is where we've been working, which is our report view. So let's go to our table view, and this is our original data set. You can see the original table. You can see we have order ID, order date, product category, quantity, unit price, cost per unit, and that's all. But right from here, under the table tools, we can create a new column. So I've showed you 3 ways of creating calculated columns. Let's click on new column. And this new column, let's call it revenue. So following the slide that we have, let's check what formula it's giving us. This is very, very simple. And it says that quantity times unit price. Okay. But then from the sales table. All right. So one thing you can do is to either write the name of the table first or just go ahead and type your quantity. Sorry, equal to first. Okay. Quantity. All right. My screen is just moving too badly. All right. So please watch something. I'm just typing quantity. And this calculated column that I'm creating, the new column stands for calculated column. It has row context. Because of the row context, this is why it is giving me this column in the first place, because once I select this column, it is going to operate row by row. It has row context. That is why I'm even seeing this. So I'm just going to click on it. So instead of typing sales quantity, I just type quantity and I got both. Then we say times. What are we multiplying it by? From the slide, what did we say we are multiplying by? Anyone who remembers? I think I only have Benedict in the class. All right. So we are multiplying this by unit price. So let's go back and type unit price. Let me just go ahead and finish typing unit price. Okay. So you can see that unit price I'm trying to type, it also has, it's the same row context. So you can see unit price right here from the sales table. I'm not looking for cost per unit. I'm looking for unit price. So once I click on this is my DAX for calculated columns. So these calculated columns that we've been talking about, if you didn't know what it is, that is it right here. Now watch what is going to happen. The moment I hit enter, it's going to apply it over here. So you can see that the revenue I created here has been applied here as a new column. Now, this column was able to generate an amount by performing a multiplication between quantity and unit price. And then it generated this. Is this row context or filter context? What do you think? Is this row context or filter context? All right, so this is row context. Okay, so keep this terminology in mind because this is really going to help for you to understand that this is the environment in which this calculated column operates. If in your mind you know that data is evaluated row by row, it helps you to have the right foundation for DAX. And after row context, we look at filter context as well. All right. Let's try another demo. And this time we are creating a measure with some X. And we are calculating what is called revenue 2. Now, let's demonstrate this and see. So we want to create a measure. All right. So to create a measure, let's go back to table tools and we have new measure. So new measure. All right. So this new measure, we want to call it revenue 2. So please watch this. So revenue, underscore 2 equals, watch this. Let's type quantity again. You can see that I just typed Q and something is not happening. Something is not happening. Who can tell me what is not happening? With the calculated column, by the time we got here, with the right equal sign here, something should have happened, but with this, something is not happening. What is not happening? What have you noticed that is not happening? What have you noticed that is not happening? Okay. So you can tell clearly that IntelliSense is not working. You are not seeing the sales table and its quantity. You are not seeing it. The reason is that what we are creating is not a calculated column or a column. It is called a measure. And a measure does not have row context. Please type that in the chat for me. Measures do not, or a measure does not have row context. A measure does not have row context. So what I thought is a measure. Okay. So by this time, you should know what a column, a calculated column is, and you should know what a measure is. Okay, we'll talk more about them. But you need to understand that a measure does not have row context. Just keep that in mind, because what we are talking about, they are just concepts, they are just ideas. They are just understanding that you should have at the back of your mind, and that will help you be able to understand that. So if you understand calculated columns, if you understand measures, if you understand row context and filter context, then you've made a lot of progress to be able to write code and understand it. So it's just like someone who is trying to do step 5 when they've not done step 1. All right. I don't know which example to give you. All right. So this is not working, but notice if you ever want to create a measure and implement row context, we mentioned before, if anyone remembers, that there are some functions that can let you create row context with measures. But then we have said that measures by default do not have row context. So a measure by default doesn't have row context, but there's a function you can use to create row context with a measure. What is that function? If anyone understands or remembers, what is a function we can use to create row context, even though we are dealing with a measure? So it's called SUMX. So I'm going to type SUMX. And after typing SUMX, let me open parentheses and watch something. Now that we have parentheses opened, let me type quantity again. Okay, so over here, watch this, watch this. SUMX has this particular syntax. You need to call the table first before you provide your expression. So the table we are dealing with is called sales. So I'll just type sales and I'll click on it, or I just bring comma. You can see that now we've moved to expressions. So now let's provide our expression. Now watch this. If I type quantity, do you see that row context is now working? Let me know if you can see that. Okay, so row context is now working because of the SUMX. So for revenue 2, we'll say quantity times unit price again. And you can see that it's also working. And we can close it now. And if you have not closed it, you are going to see a red open parenthesis. And anytime you see red open parenthesis, it means you have not closed it. So anytime you see red, look for where you need to close and close it, and the red will be gone. So when I hit enter, you can see that I have created a measure. Now the measure can be found right here amongst my columns, but you can see that this measure is not a column, so it's not supposed to appear here. All right. However, I can go to my report view and create a table visual. I'm going to create a table visual. And this table visual, I want to put some fields on it. Let me enlarge it a little bit to somewhere here. And I'm going to select products, and I'm going to select quantity, and I'm going to select revenue and revenue 2. Revenue and revenue 2. That's so interesting. All right. So let's see what we can do over here. Okay, so let's watch this. Let's watch this. Now, what I'm going to show you right now, what I'm going to show you is simple. Let me just zoom in and show you. Now, you can see that we have kind of a pivot table here, and you can see sum of revenue. This one, is this calculated column, or this is a measure? Is this a calculated column or a measure? Okay, is this a calculated column or a measure? And I hope someone is not going to say that it's a measure, it's a calculated column. Thank you, David. You're so smart. All right. Now, the revenue 2 that we created as a measure, you can see that revenue 2 also got row context because it was able to process the sum row by row. So this sum or sum X is different from the usual sum that you have. You can see that this one has row context. How do you know? Look at the value here and the value here. Are they the same? Tell me if they are the same. Are they the same? They are the same. This means that we were able to use a measure to create a loop or looped calculation from one row to the other, and this is referred to as row context. So this is row context in action. Again, when you are learning DAX and you don't have this understanding, you may find it very difficult. But then if certain things are clear in your mind, then you may have it easy. Understanding row context and filter context is crucial. These two concepts determine how calculations behave in Power BI and are the foundation behind functions like calculate or SumX and many more. What is a context? In DAX, context refers to the environment in which a DAX formula is evaluated. So which environment is a DAX formula evaluated? The measure we created is a formula. The measure is a formula. But in which environment is it evaluated? Is it row context or filter context? And you should be able to tell. How will you be able to tell? That is, if data is processed row by row or evaluated row by row, then you know that it is what? Row context. But if it doesn't use that approach, and it processes data in a different way, then you should understand that we call that filter context. So filter context exists when filters, please type filters in the chat for me. Filters. Filter context exists when filters are applied to columns or tables. Thank you, David. When filters are applied to columns or tables before a calculation is performed. All right, so please listen to this. Sometimes filters are applied before a calculation is performed. So when a filter is applied through slices and filters and charts and whatever, those filters filter the data and perform the calculation. And this context describes how rows are included or describes which rows are included in the calculation. It is also created automatically by visual elements like slices, filters, and charts. They create filter context automatically. For example, you can find the total sales with a sum function. But then when you click on female distribution, you realize that the total sales will change based upon what you clicked upon. And so when you click, it removes some rows and only works with certain rows. So it determines which rows should be included. We use filter context in page level and report level filters. And also, anytime you use the functions like calculate to modify current filters, we have filter context. Think of it like filter context narrows down the data before the calculation runs. All right. So filter is simply the act of creating a subset of your data. For example, when you click on female, it means it should focus only on female data. So it keeps every female record in mind and uses that to perform the calculations, whether total, whether any other metric, it uses only female data. So it has a filter context. It has a filter before operating. Now, row context doesn't have a filter, but then row context enters the table and reads data row by row. Filter context will use a filter to sieve out the data and get its results. And then that result is evaluated by its functions. Put simply, filter context is the idea that Power BI filters data first, then performs a calculation. So once data is filtered and calculation is performed, we call that filter context. Measures always require filter context to return meaningful results. So you can see that measures always require filter context. And when we go back to this, you can see that over here, it says that calculated columns automatically have row context. That is why when we demonstrated, you saw that it had row context, but measures do not have row context. You saw that here, unless you use functions like SUMX to create it. So when we use SUMX, we're able to create row context. When it comes to filters, if your calculation returns a total based on selected filters, then filter context is at work. It defines which subset of data is used during evaluation. Filter context is a set of filters that Power BI applies to data before a formula is calculated. And filter context is applied before calculation. All right. So Before we quickly talk about the next one, and we'll take a short break, let me do a quick demo, and I want you to tell me whether this is row context or filter context. So we have this same data set here, or this same visual table visual. Let's add what is called a slicer to it, and let's select category from here. As a selected category, we can see that our slicer, we can see that our slicer over here has multiple categories. And what we can do here is to click on one of the categories like computers. Now, the moment you click on computers, behind the scenes, what happened was that the data was filtered. This has nothing to do with the concept of row context. But this one is saying the data was filtered. And whatever is happening here is happening based upon the filter that was created. And so all that we are doing here, there are automatic formulas that are being activated behind the scenes. So as a Power BI analyst, you are going to be asked what context is being evaluated in this scenario when we have a slicer and we are able to slice our data. What context is being applied here right now? Who can tell me? Okay, so the first person says this is called filter context. All right. So what I'm going to urge you before we finish learning DAX is for you to keep in your mind what is row context and what is filter context. It is a concept and it allows you to think about how data is processed with DAX formulas. And that is the foundation to learning DAX. Knowing calculated columns and measures, those are very easy. But understanding filter context and row context makes it really, really great and gives you a step forward. All right, so there's something called context transition. And context transition happens when row context is converted into filter context, usually inside a calculated function. So row context can also be converted to filter context, and we call that context transition. Why it matters? That needs filter context to evaluate measures. When you calculate, or when you use calculate as a function inside a row context, like in a calculated column, it transforms the current row into a filter, making your measures work more as expected. That same way, if you have a measure, you can also convert it into row context by using some X, which we have tried. So the concept of context transition is also available, and this really establishes what Power BI is. We'll take a short break. When we resume, we'll talk about certain terminologies that you should pay attention to understand the foundations of DAX. And after we are done with the theories, then we'll continue with the practicals. So today we'll cover the beginner introductory part, and then in our next lesson, we will get into advanced coding. All right, so let's take 10 minutes break and we'll resume. All right, so welcome back from the short break, and we have been looking at DAX as a formula language in Power BI, and we've been able to establish what DAX is, which applications uses DAX. We've seen that we have Power BI, we have Power Pivots, we have SSAS, tabular model, we have Azure Analysis Services, and of course, Microsoft Fabric. They all work with DAX. And we have understood that DAX is a formula language. We have understood certain core concepts of DAX. And these core concepts are the core concepts we need to cement to be able to understand DAX. So first of all, we have calculated columns, which we have seen what they are. We also have measures, which we have seen what they are. We also have row context, and we have filter context, and we have seen what they are. Now, let's focus on some key terminologies. We may come across some of the concepts we've already talked about, but these are key terminologies we need to understand, and then we will wrap up the first part of the training. Right. So the first set of concepts that we need to understand, which are key terminologies in DAX, to get a hold of the language, is to understand what a measure is. So a measure is a dynamic calculation, and it summarizes data evaluated based on filter context. So here you know that measures work with filter context. We also have calculated columns, which is a column, a new column added using DAX formulas. And it also calculates based on row context or row by row and stored in memory. So these are two concepts you need to understand. We have calculated tables, which are new tables generated using DAX formulas. And so if you want to use DAX, you either create a measure, a calculated column, a calculated table. You see, understanding this really breaks down the foundation for you to understand how to handle your DAX. We also have what is called an expression. An expression is simply a combination of values, functions with operators that returns a single result. So if you have an expression, you can have operands and operators, and they will perform together. We call that as an expression. So if you say 2x plus y is an expression in maths, and if you say quantity times unit price is an expression in Power BI. And then we also need to understand the concept of functions. So in DAX, we have built-in functions. We have sum, we have calculate, we have filter, we have max, min, and others. And we have seen some of the iterator functions like SUMX, and they are all used in DAX formula. So these are just quick concepts to brush up on. Then we have evaluation context, row context, the context that enables, the context that evaluates each row individually, especially in calculated columns, is referred to as row context. Filter context, the filter applied through visuals, slices, or DAX. So you can use DAX to apply a filter context. But then anytime you use a slicer or a filter in your visuals, you are applying filter context, and it affects the calculation results. So when the calculation is being performed based on the filter context, we call that, based on the filters and the slices, we call that filter context. Then we have context transition, which we just talked about, which is the automatic conversion from row context to filter context inside calculate function. Then filters and logic. What is a filter? A filter is a condition that restricts rows and values evaluated. So when you apply a filter, it restricts rows and values evaluated. We are just mentioning key terminologies that we need to have an idea of to be able to explore DAX really well. We have filter propagation, which is how filters flow through relationships between tables. How filters flow through relationships. We remember filter direction some time ago, and we said there are two types of filter directions. Who can remember the filter directions we talked about in our Power BI lessons? We talked about filter directions. We mentioned two types. What are the two types, if anybody can remember? And I just want to, all right. All right. So thank you very much. We have single and we have both directions. So if it is single, you can see that the arrow is pointing from one table to the next. And if it is both, then you can see that it is in both ways. So that is it. So we also have filter functions, and DAX has functions to manipulate filters. So you can write DAX code to filter. We have called a function called filter. We have a function called all. We have a function called remove filters. So as we get into functions, you realize that there are categories of functions. We have iterator functions, aggregation functions, and filter functions, and multiple types of functions. All right, so all and remove filter functions. Functions used to remove or ignore filters in a calculation. Then for time intelligence, we have time intelligence functions as well. These are built-in DAX functions that work with time-based data. So YTD, MTD, year-to-date, month-to-date, etc. They are all time intelligence functions in DAX. We have date table, calendar table, which is a continuous date range table marked for time and intelligence use. So we'll spend some time later on date tables and calendar tables because in our previous classes, we didn't really do justice to them. And so before we end it, we'll definitely spend some time on them before we move on. Then we have dates, Y2D, YTD, year to date. We have previous months, all functions, examples of time functions used for date comparison and tracking in DAX. Then we have what is called iterators. Iterators are functions that evaluate an expression for each row of a table. So example is sum x and average x. So these are two functions you have just been introduced to. And today we try sum x. And so you have an idea of how sum x works. And if you know how sum x works, you have an idea how average x also will work. And we have x functions. X functions are functions in DAX that ends with x that iterate over tables while applying calculations. So it applies calculations, but it applies it in a loop. It iterates, so we call them iterators. So these are wonderful terminologies and concepts to keep in mind. Then lastly, we have variables and conditional logic. So if you type var, var stores intermediate values in DAX to simplify and optimize expressions. So we are going to be working with that with var, and we're also going to work with return. Return is used after var to return the final result of the formula. We will also use if and switch. These are conditional logic functions that return values based on specified conditions. By the time we are done with our DAX lessons, we would have covered these important, all the important concepts that will help us have a strong foundation in DAX. So this is rather the last one. It says relationship or data modeling terms. We have relationship, a defined connection between two tables in a data model. We have cardinality, the type of relationship, one-to-one, many-to-many, etc. We have cross-filtering, that's the cross-filter directions we talked about. Filters flow between related tables, single or both. Single or both. So thank you, Benedict, for that. And we have inactive relationships, a defined relationship that is not active until it is made active using a function in DAX called use relationship. So your DAX journey, all that we are saying, that for you to understand DAX, you should have journeyed from understanding what tables are, understanding what fields and records are, understanding what primary keys are, understanding what foreign keys are, understanding what relationships are, understanding what cardinality is, understanding cross filtering, understanding fact tables, dimension tables, understanding data models, understanding calculated columns, understanding measures, understanding row context, filter context, and context transitions. So have you built that foundation of understanding? Is there anyone who understands all of these things I've mentioned? Is there anyone who understands all of these things I've mentioned? Because this is what we have treated in all of our previous lessons to date. So if you have an idea, when I say primary key, you know what it is. When I say foreign key, you know what it is. When I say data model, you know what I'm talking about. When I say fact tables, dimension tables, relationships, cardinality, cross filtering, if you understand all these things, then it means you have the foundation. So what we are saying here is that these are key terminologies and core concepts that build the foundation for you to build DAX upon it. But then if you haven't spent time knowing what a foreign key is, what a record is, what a row field is, what a relationship is, what cardinality is, if you've not been introduced to those things yet, then that means you have more knowledge gaps to fill. And so you go through all our previous lessons. We've had 7 powerful lessons, and then you get yourself up to date. And from there, you will understand all of these things because we've dealt with them. And now, with all of this that we have covered, you have really built a great foundation. And I thought we were done. There's one more. So one more here, we have blank, which is a special value representing null or empty. We have error, which is a result indicating a failed calculation. So these are just terminologies. Then we have syntax, which refers to the rules for writing valid DAX expressions. We have data type, data type defines the kind of data, whether it is text, numbers, dates, strings, Boolean, and so on, used in columns and results. Of course, strings and Boolean, I'm referring to Python data types. Then data category, a metadata label that informs how data should be visualized. Example, country, URL, etc. Evaluation order, the sequence in which expressions and functions are evaluated, either from top to bottom or otherwise. All right. So after covering all of these, we have basic DAX syntax, and we also have a simple exercise after this. We have divided this lesson into part 1 and part 2. So we can decide to end part 1 here, even though we have some slides to cover. And also we have certain exercises which we can still leave for part 2, but part 1 is really a good introduction to DAX for us to have the right foundation. And so thank you all. I wish you all the best, and I want you to keep learning, keep studying, keep advancing your skills. And what you are learning today is going to be helpful, and you are going to need it tomorrow. So thank you for joining, and I will see you in the next class. Have a wonderful evening, have a wonderful weekend, and I will see you on Monday. I wish you all the best. Have a wonderful evening. Bye-bye.